Okay, so now we're going to get into question 4 here on page 39, where we're given an original f of x along with points, and we need to describe the transformations happening to graph k of x and m of x. So the first thing to do is, again, to write out our points on f of x, as well as labeling our points. In this case, I just did a, b, c, and d. The reason why I do this is because when we look at k of x, we want to compare the points to the right ones. So as you can see, point A and point B have a very distinct flat portion, and that's how we know that there's actually been a reflection, and that means that we have a negative B value. Because where we had the flat portion on f of x, it is on the other side of the y-axis, along with this kind of upside down triangle thing. So that means that it is reflected along the x. In other words, it's reflected on the y, which means our x values are changing sign, meaning we have a negative b value. Now we're going to look for any stretches first. So the way we do that is by looking at the distances between the points. So if we look at the difference between a and b in the x here is 4. Originally, it was also 4. If we look at the difference between b and c, it's 0 and negative 2, so 2, and then negative 2 and 0, so it's also 2. Meaning we do not have a horizontal stretch here, or we have a b value of 1, which in this case is negative. Next, we're going to look at a vertical stretch. So again, we're looking between points D and C. The difference in the vertical is 5. The difference between C and D here is 3 and negative 2, also 5. If we look at the difference between C and D, from negative 2 to 2 is 6. From 4 to negative 2, also 6. Meaning our A value is still just 1. This means that we need to figure out what the transformations are to go from our Y values and our X values. So if we look at, we'll pick point A. So negative 6, 4 has to somehow turn into 4 and 2. So we know that there's a reflection. So in other words, we now have to go from point 6, 4 to 4, 2. So the way that we can go from 6 to 4 is by going 2 left, or a value of negative 2. The way we go from 4 to 2 is by going 2 down, also negative 2. So now we can take all of these values. So we have a C value of negative 2, a D value of negative 2, an A value of 1, and a D value of negative 1. And we can now write K of x in terms of f of x. So we can write K of x is equal to 1 f of negative x, or the negative should be there, x minus negative 2, close those brackets, minus 2. And now what we're left with is K of x is equal to f of negative x plus 2 minus 2. And that's how we can write K of x in terms of f of x. So now moving on to 4b, again, the first thing we're going to do is label our points. So we have a, b, c, and d. This is going to be negative 4, 0, negative 2, 0, negative 1, negative 6, and then we have 0, negative 1. So the first thing we're going to do again is look for any reflections. In this, it does not appear to have any. A and B is on the right side. C is below the x-axis, so there's no reflections there. What we can look at is the stretches first. So as mentioned, the difference between A and B in f of x was 4. However, here we only have a difference of 2. And the difference between B and C in the x is 2, whereas here it is only 1. So what that means is that we've seen a horizontal stretch by a value of 1/2, which means B is equal to 2. So that alone tells us our B value. Again, there's no reflection, so it stays positive. The next thing is a vertical stretch. So if we look at the difference between B and C, for example, the difference before was 6, and it is still 6, because the difference between 0 and negative 6 is still 6, which means that we have an A value of 1, because again, no reflections or anything. Lastly, we just need to figure out what the translations are. So I'm going to use the point C, because C will be unaffected from any horizontal stretch. So this means that we go from 0 to negative 1, which means C is equal to negative 1. And then finally, we can pick any point we want to figure out D. So I'm actually just going to use point D. So we go from 3 to -1, which means D is equal to -4, because again, we're going from the 3y value down to a -1. So it's 4, as well the difference between -2 and -6 is 4, and 4 and 0 and 4 and 0. Which means that we can write m of x is equal to 1 f of 2 x minus -1 minus 4, which then, when we simplify, is going to be equal to f of 2 x plus 1, we got to close those brackets, minus 4, and that is our final equation. So again, the first thing you want to look for is stretches, then translations. However, that's all for this one. If you're looking for any customized help, you can check the link below.